Why do I have no noise? That would be why. Okay. All right, so we are talking about fitting a line to data or line of best fit today. So your first couple of problems, first vocab words. So you have scatter plot. That's a graph that you use to determine whether there is a relationship between a set of data. If there is a relationship, that relationship is called correlation. There are three types of correlation. There is positive correlation, which looks like a positive slope. Essentially, correlation means slope. So positive correlation looks like a positive slope. Negative correlation looks like a negative slope. And then if we have no correlation, that's like when we have a total scatter plot, all of our data is scattered everywhere. That's no correlation. Okay, so the goal is to derive the equation of the line that will best fit the data. That's the goal. Okay, so in general, your line needs to stay between the data. Stay between the data points. Okay, so when we look at, here's our data, does it make sense to draw the line kind of in the middle of your data points? The answer is yes. So this is confusing to some kids. You don't actually have to hit data points. You don't have to do that. You just need to draw a line somewhere through your data. So you could do something like this. Like notice I didn't really even hit any data points. I just drew a line kind of in the middle of my data. Okay. So now we're going to look at, we'll come back to that. So we are going to write a line of best fit. All right, so I want you to look at where it says 5.6. You're going to flip the page. Okay, so you're going to flip the page where you see all of those graphs, and we're going to talk about the correlation. So let's see. All right, so we're on this page right here with all the graphs and the correlation. So I'm going to pause the video. Okay, so whenever we try to find the equation for a line of best fit, you first graph your points, then you're going to pick 2 points on your line, and then you're going to find the slope between the 2 points and find the intercept, and then write the equation. So for example 1, first thing we're going to do, so the points are already plotted. What we're going to do is we're going to draw a line through them. Obviously, for a line of best fit, we all could have different answers, but they should be close to each other. Like our answers should be somewhat similar. So if I draw a line through this, so what I need to do is I need to pick 2 points on my graph that my line went through. So look where your line goes through, and you're going to pick 2 points. We're going to pick 2 points from my line, so we're all doing the same thing. So I could say that it goes through maybe like this point looks like 6, 8.5. And then I could say maybe right here looks like 0, 2. So then we need to find the slope between them. So m equals 8.5 minus 2 over 6 minus 0. Okay, so 8.5 minus 2 would be 6.5 over 6. Okay, so if I want to write that as a fraction, I would write that as 13 over 12. So that is my slope. What's my intercept, my y-intercept? Yeah. 2. Okay, so my b is 2. So then I just need to write my equation. Y equals 13 over 12 x plus 2. And that would be my equation for my line of best fit. Okay, so this next part we have some data to look at. So the table shows the number of injured birds a person rehabilitated out of vet service. Write an equation that models the number of birds as a function of the number of years since 1995. So that means that 1995 would be, like if I had 1995 on this graph, it would equal 0. So what would 1997 equal? 2. Yes, and then 98 would be 3, 4, and 5. So what I'm saying is that 1995 is my starting year. So like if I need to graph this coordinate right here, I'm going to graph 2, 8 instead of 1997, 8. Okay. So then I'm going to go and I'm going to graph those points. So I need to make this smaller. Okay, so if I graph, my first point would be 2, 8 for 1997. And then 3, 11. And then this would be 4, 5. Okay, so it looks pretty linear. They are pretty close together, or at least my graph paper is. So I'm going to draw my line of best fit and try to solve it from there. Okay, so I'm going to pick 2 points and find the slope. I actually happen to go through a few of my data points. So like I went through this point right here, it looks like, and this point right here. So I can find the slope between those two. So I would do 21 minus 12 over 8 minus 4. So that'd be 9/5.
9/4.
8 minus 4?
Yep. There you go. Okay, so then I need to find the intercept.
Ella responded and she didn't understand what I meant. And I just asked her if she wanted to do a Google Meet in algebra. So I just tell her that there's just going to be a video.
Yeah,
of normal.
yeah. Okay, so what does it look like my intercept is? If you had a rough guess.
2, 3, 5. 2.
So it's right here. Like 2.5 probably. So then my equation would be y equals 9/4 x plus 2.5. Okay. Does everybody feel okay with writing the equation? Kind of. We're going to go to the next set of notes. All right, so 5.7, we are predicting with linear models. So here's a couple of vocab words. So best fitting line, or the line of best fit, is a line that most closely follows the trend in the data. And so here we have interpolation versus extrapolation. So these are kind of funky words, but interpolation means you're approximating a value between two known values. So like you're approximating a value that's on your graph internally between other points, okay? Extrapolation is if I ask you to approximate a value that would be outside of your graph, where you would have to like really predict beyond your graphed points, okay? This will make more sense here in a minute. So in general, interpolation would be more accurate than extrapolation because interpolation would be on your graph to look at. Extrapolation would be way off your graph, or it could be less accurate, okay? All right, so this table shows the number of participants in U.S. youth softball during the period 1997 to 2001. Predict the year in which the number of youth softball participants reaches 1.2 million, okay? So here we have a graph or a chart we're looking at. So for example, if I'm asking predict when it is around 1.2 million, right? Is this going to be in between your data or outside of your data? So that's going to be outside of your data. So this is extrapolation. Okay. So we are going to have our starting year as 1997. So if I were to graph this, it would be 0, 1.44. And then this would be 1, 2, 3, 4. Okay, so what we're going to do, you guys have a graph on there? Yes. Okay, so we are going to graph this. So again, 1997 is 0. Okay, I guess that's going to stay there. All right, so 1997 is 0. So I'm going to plot the point 0, 1.44 as best as I can. And then you're going to go from there. So like 1, 1.4. And these are all going to look like they're right beside each other. Okay, so if I have to draw a line of best fit, these look like they're pretty much going in order. My intercept is that first point. So my y-intercept is 1.44. And then what I would do personally to get the slope is I would just take my first point and my last point and put them in the slope formula. So I would work with the point 0, 1.44. And then I would use 4, 1.355, and I would do the slope formula. So m equals 1.44 minus 1.355 over 0 minus 4. Okay, I end up getting negative, when I change it to a fraction, negative 17 over 800. So my equation would be y equals negative 17 over 800 plus 1.44. And the reason I change it to a fraction is because it's a little more accurate than rounding.
Forgot the X.
I did. There you go. Okay, so the next part is, it says approximate the number of participants in 2003. Okay, so if the year 1997 was 0, what would 2003 be?
6.
6. So basically I'm taking X and plugging in 6 to find Y. So Y equals negative 17 over 800 times 6 plus 1.44.
If I saw that fraction, I would have assumed I got something wrong.
Yeah,
Wait, where did you get 2003?
it says that on the paper, approximate the number of participants in 2003.
Oh, thank you.
Okay, so I end up getting 1.3125, which stands, this is in millions. Okay, so that next part, you see a vocab word that says 0 of a function. So a 0 of a function is the x value for which f of x equals 0 or y equals 0. So this is essentially a 0 is the same thing as an x-intercept. We've found this before. Like we've done x-intercepts. So 0 and x-intercept mean the same exact thing. That's where your graph crosses the x-axis, is finding a 0. So when the question asks find the 0 of the function, all you're doing is substituting 0 for y. So like this, and then you solve. That's all you're doing. So you have a two-step equation. So 6 equals 2x. So x would equal 3 would be your answer. Okay, so I would like you to try this one on your own. Try this one on your own. So you're substituting 0 for y and solving for x. Okay, Ruby, what'd you do first?
I added 12 to each side.
Okay, so then you get 12 equals 3/4 x, and what would you do next? Peyton, what'd you do next?
Times each side by 3/4.
You gotta flip if you're gonna multiply.
Oh, 1/3.
So 4/3. So flip and multiply, and then you end up getting x equals 16. Okay. Now one more question. Going back to the softball example, find the 0 of the function and what would the 0 tell us? So if I plug in a 0 for y, what did y stand for in the equation for this problem? What did x stand for in the softball problem?
Year.
The years, right? The years since 1997. What would y being 0 mean? Participants. So if I plugged in y as 0, that would mean essentially how many years would it take before there was no more softball league in this particular equation. So I would subtract. So negative 1.5 equals negative 0.05x. Divide by negative 0.05.
30.
Okay. So that's saying in 30 years from 1997, this league wouldn't be going anymore. Okay, so your homework assignment is 2 different pages, but they're not going to be due tomorrow. I'm gonna have them due on Monday. So page 328 and 338 will be checked on Monday.